go ahead and talk about the three constant acceleration equations that we use in physics all year long. They're super fun. So the first one is going to be your final velocity is equal to your initial velocity plus your acceleration times change in time. Another one is your displacement is equal to your initial velocity times time plus 1/2 acceleration times time squared. Your next equation is going to be your final velocity squared is equal to your initial velocity squared plus 2 times acceleration times displacement. Cool. So let me just make sure to write down our given. So this is our initial velocity, and I bet you already know what they each are. Oftentimes we'll use the units meters per second. However, it could be like feet per second, miles per hour, any of those things. VF is going to be final velocity. And again, same units as the initial velocity and any other variation of a velocity, inch per second, whatever it is. A is acceleration, and we will oftentimes use that as meters per second squared, but it could be like kilometers per hour squared, it could be like meters per, I don't know, per hour, multiple different variations. Delta x is going to be our displacement, and we'll oftentimes measure that in meters, but again, any distance variation. What's a good one? Miles, kilometers, whatever it is. Delta t time, and we will oftentimes use seconds, but again, it could be hours, days, minutes, whatever you want. Cool. So now let's go ahead and solve a problem together. Okay, so what I always do before I read a problem, let's say, well, I guess I have to read it to know it's a constant acceleration problem, but I go ahead and write down my givens. So we have VI, VF, acceleration, delta x, and delta t. Cool. So now what I go ahead and do is I'll go ahead and read the problem to myself. Go ahead, read the problem to yourself, and then go ahead and take a guess what the givens are for VI, VF, A, X, and T, and then we'll chat together. So pause the video, try it yourself, and then we'll come back. Cool. So now that you have a chance, let's go ahead and put in the givens. So she's initially running at 4 meters per second. So meters per second, the units of that are velocity. It says initially, so that's going to be 4 meters per second. Cool. The next part, accelerates to a speed of. Okay, this word acceleration is funky in here because it makes me think, oh, that could be an acceleration. But that is just saying the person accelerates. So they get speed up, they slow down, or they change directions. 7 meters per second, that unit is velocity. It has a speed in front of it. So that is going to be 7 meters per second over, let's say, what? A period of 6 seconds. Cool. And then what I want to find is the distance. Cool. So I'll go ahead and put that as my question mark. Great. So now I have to figure out what equation I want to use. And again, I would always have like a note card handy with these equations. I think it's helpful to memorize these equations just because we'll use them all year. But again, that's a personal preference. Cool. So for all these equations, since there's 4 unknowns, we're going to have to know 3 things. So I just go ahead and go through each equation and see if it works. So I know I need something with initial velocity, final, distance, and time. Cool. So this equation, let's see, sorry about that. Final velocity, I have that, that's good. Initial velocity, I have that. I don't have acceleration. I do have time. Okay. So that equation could give us acceleration, but I don't really want acceleration. Let's look at the next one. So displacement, I don't have. Okay. Initial velocity, I have. Time, I have. Acceleration, I don't have. And then time, I have. Okay, anytime I have 2 no's, I'm not going to be able to use that equation unless I find one of the unknowns. So let's look at the last one. Final velocity, I have. Initial velocity, I have. Acceleration, don't have that. And displacement, don't have that. That equation's not going to be too helpful either. So unfortunately, it looks like the only equation I can use is the first equation because that's the only one that only has 1 unknown. So it looks like I'm going to have to find acceleration and then go back and find something else. So let's go ahead and I write the equation always down first. It really helps me avoid a silly mistake, and I recommend you do that too. And then if someone were to look over your work, they would understand the beautiful story. So final velocity is 7, initial velocity is 4, acceleration we don't know, and then time is 6. So I go ahead and do some math. And then it looks like acceleration is going to be 0.5 or 1/2 meters per second squared. Cool. So now that I find the acceleration, it looks like beautiful. I could use either the first or the second equation to go ahead and solve. I'll use the second equation. That looks easier. So I'll go ahead and write out my equation. Delta x equals vi delta t plus what? 1/2 acceleration times delta t squared. So let's see, our initial velocity, plug that in, time is 6. 1/2 acceleration is 0.5. Time is 6 squared. Beautiful. Now I got to do some fun old math, and I get my displacement to be 33 meters. Beautiful. Thanks for coming along for the ride.